Today's lesson is about review for discrete, binomial, and normal distributions. The data for discrete and binomial distributions is discrete data. For normal distribution is continuous data. For binomial distribution, a random variable x follows binomial distribution with n as the number of trials, p as the probability of success. A random variable x follows normal distribution with mean, mu, and a standard deviation sigma. The notation is this, sigma squared. PDF means a probability density function. CDF means a cumulative distribution function. CDF is the probability that random variable values less than or equal to a specific value A, while the PDF is a probability that a random variable x will take a value exactly equal to A. For discrete distribution, PDF will be found from a table. For binomial distribution, we will use graphing calculator. Binom PDF NPA to figure out PDF. Normal distribution, no PDF at all, because the data is a continuous data for normal distribution. Cumulative distribution function for discrete distribution will be found from the table 2. For binomial distribution, remember CDF means the random variables less than or equal to A. Therefore, for binomial CDF, NPA means probability of x less than or equal to A. You have to change the probability into probability of x less than or equal to A form before you use a graphing calculator. For example, if you're looking for probability of x less than A, you have to change into probability of x less than or equal to A minus 1. Then you put into calculator binomial CDF for NPA minus 1. Specific number, probability of x less than 4 means probability of x less than or equal to 3. Then you can use a calculator to figure out a probability of x less than or equal to 3. The same strategies will be applied to probability of x greater than equal to A. You have to change into 1 minus the probability of x less than A minus 1. For probability of x greater than A, you need to change into 1 minus the probability of x less than or equal to A. Let me explain to you why probability of x greater than or equal to A less than or equal to B, you will change into this. The probability of x greater than equal to A less than equal to B is here. So it will be the probability x less than or equal to B minus the probability of x less than or equal to A minus 1. For probability of x greater than a less than b, means from a plus 1 to b minus 1. That's the reason we will use a probability of x less than or equal to b minus 1 minus the probability of x less than or equal to a. In word problem, normally you see fewer than 5, means the probability x less than 5. That equals probability x less than or equal to 4. Then we can use a binomial CDF to figure out the probability for fewer than 5. No less than 8 means probability x greater than or equal to 8, which means 1 minus the probability of x less than 8. Then it equals 1 minus the probability of x less than or equal to 7. Then we can use a calculator to figure out the probability of no less than 8. Normal distribution. Since the data is continuous, probability of x less than or equal to a is equal to probability of x less than a. You can figure out all this kind of probability by using graphing calculator. Negative infinity will be changed into negative 10 to the 99th power. Positive infinity will be changed into 10 to the 99th power. Let's talk about inverse normal distribution. We will use this form to figure out inverse normal area, mu, and sigma. This area equals probability of x less than or equal to a. You have to change the probability into probability of x less than or equal to a form first in order to figure out this a. For example, if you are given probability of x greater than b equal to q, you will figure out probability of x less than equal to b equals 1 minus q. Then the b equals inverse norm 1 minus q mu sigma to figure out this b. For expected value, called mean also, variance or standard deviation. We know variance equals standard deviation squared. For discrete distribution, summation of probability equals 1. Expected value equals summation of x times the probability of random variable x equals x. For binomial distribution, expected value equals number of trials times the probability of success. Variance equals n times p times 1 minus p. Standard deviation equals square root of variance, or square root of n times p times 1 minus p.